So this is the second panel. It's the panel about EuroQCI CEF, Connecting Europe Facility. And I have another two questions prepared. It's me here, don't worry, because there's no place for another chair, so no problem. First question, as multiple EuroQCI CEF projects are being deployed across Europe simultaneously, as we have heard, and with the integration of terrestrial QKD networks and satellite links through EGLO-1, what concrete technical interoperability and coordination challenges must be addressed in the next 2 to 3 years, let's say, to avoid fragmentation and ensure a unified pan-European quantum communication infrastructure? That's a big question, but I hope you can find the words to reply. Let's start from here. Sorry. Yes, please, Mark.
Okay, thank you. Thank you very much.
Short answer, okay?
Okay, sure.
Because we can talk for days. I mean.
Okay, I will try to be as concise as possible. I think that there are three aspects of interoperability which should be underlined and should be somehow covered in the coming next 2 or 3 years. So the first one definitely is connected with the compatibility and interoperability between the OGS and the satellites, in fact. Once upon a time, Martin Luther King said famous words, "I have a dream." So I can say also that I have a dream to build the OGS when I have already the satellite flying somewhere ahead. But currently we need to install the OGS station to prepare infrastructure without having the already launched satellite. So this is definitely something what we need to collaborate closely in order to create the OGS in the same way and to be in the same place in here. The second issue which I would like to underline is the KMS interoperability and the ability to exchange data between them, because it's obvious that each country, each partner can have an impact on its own network. So it's we need to establish a ways like at C020, for example, the standard or something similar in order to exchange data between different KMS systems. And the third sentence is about is connected with something what was already mentioned by Ferdinand in the morning. So if we would like to provide the end-to-end security, we need to combine the two technologies. It's not enough to just use QKD. We need to use hybrid approaches. We need to mix QKD and PQC, and in this field, it's also good to try to find out some standards how to create the hybrid solutions in order not to do it in parallel in different ways. Thank you.
Okay, in principle, I would say the answer is easier than expected. Security comes from the key management system. If you do a hybrid solution end-to-end, you even can certify it, and it has the security of post-quantum cryptography. And then you plug in for different links the QKD keys and do some mechanisms to hybridize the solution. In reality, what we really have to learn is, and I hope that in at least one of those CEF projects, we really see different approaches to key management. Because basically in the architecture, we have two types of approaches, to forward the key hop by hop, or to centralize it, for XOR some parts of the keys centrally and de-XOR it end-to-end only. So there's this approach from Airbus and from France versus the rest of Europe so far. And in standardization, I think both solutions are there. I'm not sure if we really try in one or the other CEF project how to connect key management systems which are different in principle. So that will be one of the challenges. And the other topic is the fragmentation. In principle, I wouldn't see there's a fiber infrastructure, and you put some added value for your end customer on it. So basically each chief information security officer will have different approaches to security. So they will have different views on trusted nodes. So there will not be one infrastructure. The question is if a telecom operator can reduce costs by using, or like my next speaker, by using a trusted node for different customers. That will be one of the other challenges. Okay, hand over.
Felix?
Okay, this side. Okay, this is possible. Yeah, so there is for sure going to be fragmentation, as Martin said. And I'm sure that all the smart guys will find out how to make this all work together. So our focus, or what I think is a real challenge, is that at the end customer, be it commercial or government or military, really trust these connections. And there is no other way than to achieve the best certification level you can achieve on something like that. And according to our conversations with at least the German BSI, this is a common criteria 4+. If you don't achieve that, then you cannot claim what we all like to claim about QKD. And this involves secure software development, supplier management, and this is so whatever will be at the end, the mix of technologies and suppliers or vendors, they all have to, all in the same link, they have to have done their homework, and this takes years to implement, and this takes millions of euros to implement. And otherwise, we will have a working technology that no one really trusts. We see that in our conversations with our commercial partner or customer, this bank and the regulations regarding financial data. This is really tough. They don't care about technology. They just want to see their regulations fulfilled. Otherwise, they can trust. And this is going to be a hard one for all of us.
Next one, please.
Yeah, so I agree that mainly the focus should be the KMS, and I think with so many CEF projects, basically building towards the same idea of interoperability KMS that works cross-border, it will be definitely some duplicate work, and I think everyone should focus, even if no one likes reading and implementing standards, we should focus on doing that, like 020 that was mentioned before, or anything that basically deals with inter-KMS interoperability. I think that should be the main focus.
Yes, I would like to add that if we do not want a fragmented, isolated solution, I think also that strong European coordination is needed. We need common rules, practical interoperability data, and of course trust among the national security agencies, and let's say a minimum security baseline that all the security authorities, the governmental, the public sector will trust in order to move towards this EuroQCI realization. Also, I think that the certification of the QKD devices is of utmost important. If we do not test them and trust them, then we cannot use them for operational solutions. So I think that this is also the big bed of the European Union. And we have European projects such as Nostradamus, that it's now validated this large EU QCI infrastructure, but we will have also another CSA on certification, coordination and support action. So we are expecting the results soon. But this is also another important element for to not having fragmentation. And last but not least, we have to see the Eagle One integration, or at least a satellite with QKD. You need collaboration, coordination with the satellite operators, with the network operators, and I think that only with certification, interoperability, and EU coordination, we will succeed in having a unified EuroQCI infrastructure.
So before the CEF this phase of CEF started, we promised in Romania that the Romanian CEF project will leave aside 20% of all the keys generated for third-party consortia that need to communicate with each other through the Romanian infrastructure. I believe such approaches are very good at solving the fragmentation problem, and we will fulfill this promise. However, with the addition of optical ground station, the problem becomes much more complex. You have, for example, you need to decide obviously the obvious issues like how KMSs, different KMSs can interoperate with each other, how the interface between the optical ground station and terrestrial network to the OGS requests and response will happen, and so on. But you also have more complex issues such as how the satellite airtime, which is limited, will be scheduled, or how the optical ground station time will be scheduled among multiple space missions such as QKD SAT, QKD QSAT, and so on, and Eagle 1, Saga, and so on. Will be scheduled, which is also limited. Now in QKD there are three essential parts. First of all, we need it to be working, and for it to be working we have all these interoperability protocols. Secondly, and this is without this it is useless, is the information theoretic security. If we cannot maintain, if we cannot keep this property of information theoretic security, then doing QKD is for nothing. And then thirdly is the optimization problem that this raises, in that we would like to not leave money on the table. If you have a network, you can get more out of it. Thank you.
Okay, yeah, a lot's been already said, so I'll be brief and say I would like to underscore the point that was made with trust. I think we saw really, I thought, a really interesting spectrum of different approaches already here today, yeah? And that in one sense could be negatively interpreted as fragmentation, or it could be positively interpreted as diversity, which means we have now in the whole CEF community the possibility to test and to gain trust and to demonstrate, different approaches to build up trust. And I think the whole CEF framework has been constructed very smartly in that we are all funneling according to the regulation that we're being funded by to IRIS squared. And I think this is a very good forum because there's going to be benchmarks that we can work into in our different perspectives that we take in our different projects. And therefore, maybe as a general word that we should put forward one more. I remember in the workshop in Brussels, a very smart Italian colleague from classical networks, we were talking about what approach to take. Two possibilities in this, what was discussed in the beginning, the hop rope approach versus the top-down distribution. And he said, fully from a classical point, well, networks are alive. We don't really determine classical networks, they just grow upon demand. And I think maybe that's something we could also kind of take in this quantum community, that agnostic approaches, I think, are very good, or to incorporate in the technologies that we develop a high degree of agnostic capabilities, so that we build up base infrastructures that can adapt to the changes that will anyways come. We're still at the beginning of this technology, and it will continue to evolve. And the more agnostic we build our base infrastructure, the better the base infrastructure can further evolve as this technology progresses.
So keep the mic on. You want to say something? Yeah? Sorry?
I wanted to give a comment on Ilias, because I'm also representing the Nostradamus project, not only the BAT-QCI. And basically what is discussed there, or how is the status on certification? So I would say, for certification, you need basically three main aspects. You need accepted security proofs by the national security agencies. You need a protection profile describing the security claims of your product producers. And you need a test lab who can do and redo such channel attacks and security attacks on the physical layer, because there are the security evaluation facilities in Europe. They can do all the software analysis, what is normal with classical security connected, but the physical topics with QKD are new. So on the first topic, security proofs. There's a real difficult situation, I would say. In order to become information theoretic secure, in principle, security comes from physics, therefore also such channel attacks come from physics. So your production is with some uncertainties, so they have to be included in the security proofs, and then it becomes very complex and not very easy with all the best brains in the world to come to a security proof which includes all potential imperfections and have a consistent information theoretic security proof. On the other hand, security proof or such channel attacks means control any takeover of your detectors, which is the most difficult topic, or most easy for the attacker, and protect your transmitter with isolators in a broad frequency band, not only the one you transmit. So perhaps one can come with an acceptable security proof for different QKD approaches, which can be accepted by the NSAs, but perhaps not theoretically secure in the beginning, in the first step. The second topic and the third topics, so the protection profiles will be produced by Nostradamus for those approaches of systems which are not yet covered. So that basically means entangled systems and measurement device independent systems. That is the second. And then the lab at the Joint Research Center in ISPRA, there will be established a lab which can be used by the IT security evaluation facilities in the future, and that can be used by the national security agencies for certification. I think that infrastructure will be there quite soon. Yeah? But the fallback is then we have the security certified for one link. And then you have a network with trusted nodes, and the whole discussion starts again. So in that sense, what I really would like to ask for, which we did not achieve with the Digital Europe projects, to have a broad European discussion on trusted nodes and how in the different member states, how they are discussed, implemented, discussed with the NSAs or with security agencies. So that should be done in the hopefully RS Square coordination support action have much broader territory for discussion in Europe, because that will be relevant for any discussion with the security agencies. Thank you.
Okay, thanks a lot. Let's continue to the second question. And SEEWQCI will demonstrate 29 cross-border quantum secure connections, again engaging real end users. How important are these large-scale demonstrations in moving from experiment and pilots to fully operational and trusted quantum communication services across Europe? Let's start from the other way, down there.
Good, I get the lead on this one. I think they're highly important. We talked, Martin made a great point earlier when he asked this question at the beginning of today, in considering the costs of fiber renting being far beyond what the individual QKD systems cost, and if we're calculating this kind of thing when we're looking at real applications starting to pop in. And what we have the opportunity to do with the connectivity that we can achieve maybe in this phase of EuroQCI is truly onboard enough critical mass to make certain business models for this technology to become interesting. Yeah, we've been now working 3 years in national frameworks, and even within those frameworks, we have to be honest, those links have been limited in where they can go. Yeah, and which makes the business case for anybody, say financial, or whatever point you want to bring up. But now we have the opportunity to really start build up connectivity, and I think this is the stage where we should use the potential to demonstrate long-range connectivity for onboarding all possible points of use cases. And we also had in the panel discussion this morning, it was said that security is universal to our society. It's not just a NATO case. It's not military. It's of course NATO military, but it touches all aspects of our digital world, and therefore this would be the time to start addressing that and onboarding users in the connectivity we can demonstrate.
Next one, please.
So regarding this large number of use cases that, for example, SEEWQCI has, we've noticed in Romania as well, we've had use cases from ranging from military to medical to data centers. And it has always been very difficult to get users on board. So I think it's amazing what Greece has been able to do, and especially our friend Ilias, bringing together all these partners and consortia and having these actual use cases with real users on real infrastructure. I think this is very important in moving forward. So we are very happy to have this collaboration, especially on the technical and optimization aspects. Thank you.
Ilias, you should answer now. Of course you should.
Thank you, Alin. So, indeed, the large-scale demonstrations are crucial for towards this element. With the large-scale demonstration, you are engaging real end users. And when you have real end users, you're not just testing the system in isolation, but you are testing and validating the whole ecosystem, from the QKD devices, the orchestration layers, the key management systems. And this is the only way if you're going to have this unified EuroQCI solution. Also, I think that with the large-scale demonstrations, you can feed directly into all the gaps that you're going to reveal, because if you are not tested in real-life environments and between different stakeholders, you cannot reveal the lack in all elements, the interoperability layer, the orchestration layer, and what else is needed in order to have operational QKD services, which is another level. So that's all from my side.
Yeah. Okay, next.
So I think we all agree that these kind of demonstrations are important and more than important, because if we don't have end users in the end, then all this investment on all this work and money will be basically for nothing. So we need end users, and end users will want to work, to know first that this entire network works, and the only way for them to know that the network works is by some kind of demonstrations of, let's say, brave users that will venture into it, not knowing the final state of the project. So yeah, I think the demonstrations will mainly be useful in order to show people that, hey, what we built here really works, and if something doesn't work, then we'll find out during these demonstrations and we can fix it.
Felix?
I wouldn't be here if I wouldn't think that long distance or this cross country is very, very important. I want to touch on two things quickly. One was it was mentioned several times that fiber infrastructure seems to be expensive for QKD. When we designed our link, and we are building this link now this year between Vienna and Frankfurt, this was actually not a problem at all. We quickly found relatively cheap optical fibers for all the ways, or dark fiber. That wasn't an issue. Maybe in other parts of Europe that might be an issue. I don't know yet. But yeah, so this was easily done. And what is more of a problem, and Martin has mentioned that in the morning, that trusted nodes are pretty expensive. If you want that your customer, be it military, be it private, or be it the government, really trusts the trusted nodes, So this cybersecurity stack that you need to put in place, that is comparable to the cybersecurity stack that the owner of the data that at the end shall be encrypted with the keys. This is pretty expensive, and it's highly non-European. So you will have to rely on a lot of US technology providers, and so this is going to be a challenge more than the fiber from my perspective in terms of cost. And yeah, so this is just what I wanted to share with you from our experience in implementing QUAPITAL.
Okay. Next, yes.
So I would say in principle, the most use cases are not that relevant. Just want to provocate you. Why? Basically, the QKD will make its way to adding added value to the customers if telecom providers can show that. So in principle, we need to become part of the portfolio of telecom providers in their cybersecurity portfolios. Then the QKD suppliers really did it. Then they can survive in the long term, and it's not only funded projects and the like. So what does that mean for the CEF projects? Basically, it means that we have to work on how to work on interconnectivity between different key management systems, how to integrate that to different software-defined network systems and so on. The goal must be, I always say, zero-touch provisioning. So now, after that project, the QKD providers basically came from prototypes to stable products. The next step is to really make it that it can be integrated without a lot of effort to the telecom systems. Yeah? Because otherwise, if that's a different infrastructure for monitoring, managing, provisioning of the network, it's always a very niche market. It's not a broad acceptance in the market. So in that sense, since we have to work on interoperability, we also need to be working on acceptable solutions with the open KMS, for example, acceptable that it can be seamlessly integrated. It will not perhaps seamless, yeah, but in principle, that should be the goal to the telecom networks. That is the really interesting thing of all our activities in CEF. The other topic is what I wanted to mention, what we do in our project with the partners from Hungary. There we go for the real hardcore security solutions. So we go for biobanks, and that is really COVID-like in the labs. So security needs to be there like in the banks of my neighbor. Yeah? You have to fulfill certain rules. And what we do is, just to be sure, put end-to-end a certified link encryptor. That is already there on the market. It's relative to the solution with trusted nodes, rather cheap. Then you have at least end-to-end security, and all the other QKDs add-on, and you can learn, but you can't do the final mistake end-to-end. Yeah. So in that sense, it's cool if you have in all the CEF projects different use cases and discussion with different communities on their security. But in principle for QKD, without certification a bit early. And the next step also, which I forgot before on certification, I think there's now discussed the protection profile for the KMS. So perhaps with post-quantum cryptography, we really can go for the certification of the KMS. Then we are much closer to what the NSAs want, because you can do the link encryptor, which is certified, the KMS, which is certified, and the post-quantum cryptography provides the normal security. Until it's not broken, it's there. And QKD provides if it's not attacked, because nobody would like to attack if it's anyhow secure. So would then provide the endless security. But that's okay.
Last answer. Mark.
Okay. Okay, so maybe I can start just with amen and conclude the session, or if you like, I can add two more ideas to this, because of course I agree with all the panelists about this. Just one comment about the costs. Yeah, we are somewhere in the middle, I would like to say, yeah, because on one hand side, of course, there is a big cost, but I think that the QKD solution, all the initiative which is covered by the EuroQCI is not the solution for every problem which we have. Yeah, currently we use asymmetric cryptography everywhere. If we want to access the website, we use ciphers. We have HTTPS, everything like that. And QKD is not the solution to deliver such type of service to every client, in fact. Yeah, we are just trying to give another layer of security which has a completely different basis. It's not it's not based on the maths, in fact, on some cryptographic assumptions about like RSA or elliptic curves. Yeah, it has just completely different origins, and it's worth to underline, it's worth to find out during this scenarios realization, during these use cases, where it's really worth to invest in such type of solution for what type of traffic which we really need to protect, because definitely QKD is not to solve every encryption problem which we have. So this is one short comment about this, and another one. It's from my point of view, it's even not the number of the use cases is so impressive. The most impressive is the scale of the use cases. If we have the multiple entities involved, yeah, we are in a okay, I should start in a different way. QKD comes from the world where we control both sides on the point-to-point connection. Yeah, here when we are discussing the EuroQCI, all this initiative, we would like to extend this from the simple point-to-point to create the whole network. So all these scenarios where can you really show that it works in the similar way, you already mentioned this, that we are going into direction to the solution where it works like BGP, let's say, in the classical networking. So in every use case, even if you can demonstrate one or two where we have different networks connected and the key exchange really works there, it's something what is really valuable for the community.
Okay. And that's the end of the second panel.